The chain rule is a very powerful tool. It allows you to differentiate pretty much any function that you encounter. And if you have a function inside another function, well, that is just screaming to be differentiated by the chain rule, okay? So let me show you what I mean by a function inside another function. So now let's suppose we have y, and y is a function of x. So we have x plus 3 squared. Now initially, how do you differentiate this? Now you might think, well, we can just expand the binomial and then just differentiate each term, and that is absolutely true, you could do that. But there is another way, okay? That is, maybe even, it's actually faster. Especially if you don't know factoring rules, it's gonna help you a lot. Now, I want you to think, how can you find two functions in this expression? Or how is there a function inside another function in this expression? Basically, what you can see in there is that we have that y is a function of x squared, where x is another input. What do I mean by that? Basically, you have a number that in this case is going to be x plus 3, whatever that is, okay, it's just going to be a number, and you're going to square that. That is x squared. So that is a function that we have. Now, what I want to do is, we know inside of y, so I'm going to write it inside y, we've got x squared, okay? We've got any number that we want squared. Now, what is x going to be in this case, or what is our input going to be? Now, our input is going to be x plus 3, which is another function. Now, I'm going to call that function just simply u, okay? You can call it whatever you want. You can call it C, A, whatever, okay? I'm just going to call it u. Now, u in this case would be x plus 3. And that would give us that if we let x plus 3 be equal to u, then we have that y is just simply u squared, I'm sorry, okay? Now, you can basically, what I'm showing you is that you have a function u that is inside another function that is x squared. Basically, what you're saying is that you want to take, if u is equal to the input for x squared, well, that's just going to be u, which is x plus 3 squared, what you have up here, okay? I'm just showing you that if u is equal to x plus 3, then y is going to be equal to u squared, which is exactly what you have up here, okay? Now, how do you find the derivative of y in this case? Now, something you might do, and well, what you want to do in order to use the chain rule is you want to first of all find the inner function. Now, what is the inner function in this case? It is not x squared. We know x squared is inside y, but it is not like the most central function or the inner or deepest function. The inner function is x plus 3 because it is what you have as an input for your outside function. What is your outside function? X squared. You have a function and you're going to square whatever input you get, and that input is going to be u, okay? Now, how do you take the derivative of y? Now we know what our outside function is. With what the derivative of y with respect to x. Now we know we know what our outside function is. We know it is x squared. So now what are we gonna do? Initially, what you're gonna do is you're gonna take the derivative of y with respect to your outside function, okay? Which is going to be x squared. And we know x squared is taking as an input u. So we get y is equal to u squared. So you take the derivative of y, so you have dy with respect to u. Okay? This is why Leibniz's notation it's pretty useful, because right now you can say, well, y with respect, or y as a function of what. Okay? That's why it's useful. Now we have this. Now how much is dy over du? This is just simply, if u was like your common x, well, now you just need to differentiate this expression. And that is just simply going to give you 2u, okay? Now, what I want you to think is that if we've got 2u, in this case, we could say, maybe down here, I'm going to write it, we could say that dy over dx is equal to 2u. Okay, this is the same thing that we have up here. But now the thing is, we need to somehow also consider x plus 3, which is the input that we have. So now how do we do that? Well, if you think about it, this is just simply a fraction. And something you can do with fractions if you want to get rid of any number that you have top or bottom, in the top or in the bottom, is just simply multiply by the same number in the opposite side. So what if we want to get rid of du and only have, like, as a denominator dx? Something you could do is the following. You want to multiply by du over dx. This is pretty clever. And this is the chain rule, basically. You're going to multiply du, these two du's are going to cross out. And now we know how much this factor is. We just compute it. It's 2u, right? And now how much is this? Well, we know u is also a function. It is our inner function. So now how much is the derivative of u? So now du with respect to x, taking into account that u is equal to x plus 3, is just simply going to be 1. Because, well, you remember this is a constant and x just goes to 1. Now, what do? Well, you just simply solve this equation. So you have that dy over dx is going to be equal to what you got, so 2u times du over dx, so you can cancel out these two du's and you can have dy over dx. So how much was du times over dx? I'm sorry, that was just 1. And so you're gonna get that dy over dx is 2u. And how much is u? Well, u is just just x plus 3, which is just the same as x plus 3. Okay, and now you can just simply distribute, so you get 2x plus 6. Okay, this is the derivative you get. Now I hope you have understood what I just did. Basically, you want to break up a function that you have into pieces, okay, or into inner, or like more singular functions. And what you want to do is you want to assign the inner function. Okay, you're gonna get some intuition into knowing what is the inner function. You want to assign that inner function the value of any type of variable, okay? So that variable is a function of your inside function's input, which is x in this case, or x plus 3. And then what you want to do is you just simply want to take the derivative of the outside function and then multiply by the derivative of the inside function with respect to x, because mathematically, well, we know these two guys, they're just gonna cancel out. And you're just gonna get that you have dy over dx is equal to dy over dx. This is basically the chain rule. It is a very powerful tool, okay? And it is basically, you can differentiate almost like what? Like 65% of all the functions that you encounter, you can solve them by the chain rule, okay? So it is very important that you know it. Now, if you're getting confused with like assigning all these variables and all this notation, one way you could see it is that if you've got simply a function f that is taken as an input g of x, now, and this is, well, whatever it is, the derivative of this, so I should have wrote it a bit to the right side, so the derivative with respect to x for f of gx is just simply going to be f prime of gx. Okay, you just keep the input in the input the same thing, f prime of g of x times g prime. Okay, this is the same thing as this, although I think it is way better to use this notation, Leibniz's notation, because it just shows you how du cancels out du, and well, at the end of the day you just get dy over dx, which is what we want. But you could also see it like this. You've got an outside function with an inside function. You differentiate the outside function, keeping the inside function absolutely the same, and then you want to multiply by the derivative of what's on the inside. This is basically the chain rule. It is a very useful tool, and well, I hope you learn to use it, or at least know how it works, okay? Now in future videos we are going to be solving some problems. So I hope you guys enjoyed this video, and see you in the following one.